Good morning, good afternoon, and good evening. And thank you for joining our webinar today on Agentic Document Extraction. I am really excited for today. We're going to be discussing life science use cases, and our host and moderator, Fatima and Andrea, I work very closely with. To our audience, you have a wealth of information. Fatima is our product manager, and Andrea is our senior machine learning engineer. They are both in the trenches with our customers and prospects on a daily basis. So this is a great time to ask those questions. With that, Fatima, take it away.
Thank you, Adrian. Yeah, I will share my screen. As Adrian mentioned, today we will be going over Agentic Document Extraction, our current flagship product, and going over some of the use cases in healthcare and life sciences that ADE can solve for you. Starting with, I will go over what is a product overview, what are we actually doing with document extraction, how is it different, and what kind of documents it can support. Then going more into the examples in Visual Playground. We have two APIs, so you should be, as you're going through the presentation, you will see that we have one parse API and then an extract API. I will go deeper into those two. And then give an orientation of the APIs and documentation itself, and go over some of the questions that you will have regarding hosting, security, and then support for as you're starting with the ADE, and just pricing and subscriptions as well. A little bit about me. I am a product manager here at Landing, working on document extraction. So if you have any feedback, any questions, I am happy to answer along with Andrea. I have a background in vision products, which works well for me here, as we are taking a vision first approach to solving document problems, and also have a data analyst background. Mostly my work related to cleaning the data to make sure that the machine learning engineers can use the pure data or clean version of data, and so can understand the amount of difficulties we have with unstructured data, working with unstructured data, particularly the ones that is logged in documents. And that goes right into what is Landing, just giving a brief overview of what is Landing and what are we currently doing. Landing has a strong background in building vision models and tooling for computer vision engineers and vision engineers in different industries like manufacturing, healthcare, life science, etc., so that these models are difficult machine learning models are accessible to actual industry users. We use that to our advantage, and have also created a document extraction product, which we will be talking about today. And this document extraction product not only just reads the text out of the document, but also structures it in a way that the today's tooling that is coming downstream, which is LLMs, RAG applications, knowledge graphs, can use this data most efficiently, instead of just extracting whatever the text is and not really making sure that the data is useful for downstream applications. Landing, particularly for document extraction, can take PDFs, images, Excel sheets, docs, etc., and then convert it into more usable, machine-readable data for LLMs, RAG applications, or even just entity extraction or field extraction to extract only certain elements from the document. We are founded by Dr. Andrew Ng. He is well known in machine learning and data science space. And under his leadership, we have been able to process about 1 billion images and documents so far. And we are excited to go forward and have a long way to go. So about document extraction itself, we are an API first product. What we do with ADE is that convert all these documents, use reasoning on understanding how the documents look like, and then chunk it up in different parts, group information together. Let's say you have patient information, it will be all grouped together. Maybe the test results are in a table, which will be detected as a separate table and grouped as a table, and then extract the information from them. And what we do is we convert it into a Markdown and JSON. Markdown is particularly useful for your LLMs, which can take in Markdown and then answer questions on top of that. We also provide a structured JSON. This is very helpful. I will talk more about visual grounding, ground where exactly information is coming from. We also have an API that can convert information into structured data, which will also be outputted in JSON. And so where is the useful? Which downstream task we are generally seeing right now? The first is field extraction, and then the second is preparation for RAG. For field extraction is something like you have a document and you want to extract very specific information from this document. So for example, you have a patient intake form and you want to extract information about the patient. You have a test result or test report. You want to extract information from those test report pertaining to one particular test. So all this kind of like very specific information can be extracted on top of like our APIs. We also have RAG as a second application that our users engage in. This is to feed the whole markdown that is extracted to LLM and repeatedly ask questions from it to get in chat output if you have a Q&A or chatbot downstream, or if you have like some kind of automation to write queries in database. So going deeper into field extraction use case, as I mentioned, if you have like a bunch of data, maybe invoices, maybe like test results, and you want to extract information from all of them, field extraction use case will be able to convert these documents take this in, convert it into a markdown, and then convert it into more structured format of information such as invoice, date, etc. here. In terms of RAG applications, this is more useful if you have like different kinds of reports from which you have to answer questions that the users might have, or even knowledge workers that can have inside the organization. And what we can do is like have ADE parse all the documents that you want to feed into the RAG system, and then provide a markdown as an output, which you can store in a vector database and answer users' queries. Couple of features I wanted to highlight before going into the playground itself. First is it does not require any training for you to get started with ADE. So it can detect any kind of layout, be it like multi-column, scan documents, even if the same lab report is like changing a layout over time, it doesn't matter. Like it should be able to detect as many layouts as possible with just one API. You don't need any kind of training to detect or parse a single document, which means that it can scale very well based on your workload. You don't require any kind of intervention as you're going forward with a new project, or even like existing project changes layout, etc. The second feature that is very useful for our users is visual grounding. So every information that is extracted from the document, it is visually grounded with a bounding box with normalized coordinates. So for example, this logo of Slack is grounded with the bounding box location and the page number from where it was found from. And this will help us have an audit trail. If you have human in loop, they can have an audit trail to like verify if the information is correct before storing or like processing that information. Or it can also help users in RAG chatbots or Q&A bots to like find the references where this data or answer is coming from. And so if they want to like verify if this answer is correct, they can just go back easily to the document itself. And then lastly, for field extraction itself, we provide you with ability to like provide a schema. So you can provide exactly what you need from the document, and it should be able to answer or output the values for that particular schema or fields that you are interested in, but also provide the same references of like where this particular information came from in extraction. And all of this is converted into a developer-friendly JSON. We have API documentations that I will also go over. This JSON will help you like have structured information that you can use downstream. We deal with a lot of document messiness, particularly in life science as well. What we have seen that patient intake forms come in various layouts. Even test reports have varied layouts, and sometimes the test report changes layout over the course of time. And so all of these layouts can be handled with ADE. We also handle scan pages or handwritten pages that could be doctor's notes or doctor's patient intake forms as well, have handwritten information. We handle multiple languages. We have a list of languages, but it is like pretty long. So we should be able to handle all the languages that are commonly seen. We handle like cell phone photos, inconsistent formats, rotated contents, like if the document is or page is rotated, check boxes and circles, which are often seen in intake forms again. And then detecting signatures or stamps as a separate class, and understanding if the signature is present or not present. So based on this, I will go into examples, and then we can take some questions. So as you land on landing.ai, you should be able to start for free. And this is the agentic document extraction product that we are talking about. Once you click on that, you will land in this playground. This playground, you can have agentic document extraction as the product that you're interested in, and then you will end up here. Here you can get started with just like dropping a file. So I will quickly drop one file and show the extraction or parsing. And so this is a very simple document which has like some text elements here, but it also has a figure or a logo here. And this information, you need to like make sure that the exam, the values, the result or the value for the exam, what exam the medical report is about, is connected together. This gender and the gender value is connected together. They are not like two separate entities, but they are like the gender is female. And then you have like a signature as well. So I will go over some of the things that we did here in Extract. First, what we did is like grouped information together, as I was saying earlier. What it does is that it doesn't like mess up which information is connected together. So the study date and this particular study date is part of one group. Once we group the information together, we classified it. Here you can see that this is classified as a figure, this is classified as a text, and then this is classified as an attestation, or because it has a signature. And after classification, we extracted the information as it is, like we extracted everything. So this data is still unstructured, but now you have this in machine readable format. You should be able to view the JSON here, where we provide the markdown for each component or each chunk with the type, like what is the classification for that, and ID, which is very helpful for the next set of APIs that we have, which something like extract. And then grounding. So grounding is the bounding box location of where this bounding box is on the page, and then the page number itself. These are normalized coordinates. So you should be able to like build this UI on your side if you want to reference the information on the page and the document. And then for attestation, so we extracted the text as it is. For attestation itself, we identified that this is a signature. The signature is present, but it's not able to like clearly read the whole signature. It still extracted all the other information correctly. But it did say that it is signed and verified. Apart from that, I will go over some of the other examples which I have run already. So let's go through other test reports. For this one, there is more chunk types or like grouping types. This, for examples, are scan codes. This is a barcode and a QR code that is extracted separately. Then we have a whole bounding box around the table header, all the grouping of like what is relevant to the table is also present inside the table. And since this table is complex, it doesn't have any kind of grid lines of like where particular line ends. We are still able to extract and connect the information together. So for example, hemoglobin, and there is hemoglobin HB. This is all part of one row. And this extracted information is like matched to the rows in the following columns. Again, here as well, there is some signatures present, which is detected as attestations. Here, I wanted to highlight one thing that keeps coming up, like how we are different than OCR. If you had something like an OCR, what it will do is it will not be able to intelligently understand which groups of information are together. So for example, it will start reading like Yash Patil, then go here, sample collected at, and then keep going in the same line. Then it will go for age, and then it will go for this address. So if you want to like extract or find out the value for where is the sample collected at, you won't be able to locate it because the information is now jumbled in the extracted markdown. And going into deeper, let's like see how we can visually ground the information. let me ask a complex question here. So these are just some example prompts that our chat app provides. Our chat is not an API. We just have it on the playground so you can see the art of the possible, or like what you can do with our parse results downstream. So maybe I will ask the questions about hemoglobin count and the result for hemoglobin, and then how does it relate to the reference value. And so I will use this example. What is the hemoglobin result for Yash and Patel, and how does it compare to the reference value? So it provided the answer that it is 12.5 grams per dl. And this unit, it is able to find this unit because all the information is part of one chunk, and it can understand that all this information is connected together. And then it also is able to extract the reference value. And then here you can see that based on our parsed output, it's able to relate where this information is coming from. So if I click on this, it will show me the exact cell where the 12.5 came from. It will also show me the exact cell where the reference value came from, which was the question that we asked. You can actually ask questions about anything, maybe like age of the patient. And it should be able to relate back to the exact chunk where that information is coming from. I will go ahead and just show you a couple of more test reports. This is another test report. It has the same issue with like not having any kind of grid lines in the table, but it's still able to extract. This is another table. We are able to detect multiple tables in the document and then also extract the information from them. This is more of an unstructured results, but it is still, sorry, this is a patient. This is still like a faxed report from a document or a hospital. And it has like information that looks like this, where you have like a column of just information about the doctors and practitioners. And this is the information about about like what happened on the day itself. It's still able to like not connect them all together so that the information is jumbled. It's able to like connect the information that is together and then order them in the right way. So like this is like the starting point of like this is first, this is third, fifth, third, fourth, and then fifth, then sixth, seventh. So it's able to order all this information so you can like have them in the right order to answer information in either the chatbot or the extract. I have some handwritten samples as well to show here. For example, this is a patient intake form, which has checkboxes and a very simple handwritten information. It's able to detect the checkbox and also extract it as like yes, and then X mark because it's detected as yes. For the handwritten sample itself, it's able to extract the information here. If you look at this another sample, this doesn't have checkboxes. This has one checkboxes here, but it has more of a circled answers where there are options. It's still able to like extract the values, like what are the options, and then correctly select the ones that was circled. Same here, where it's able to detect that option asthma is circled and eye infection is circled. I have these examples. I can take more questions here, Adrian.
Great. We've got some questions. Let me go ahead and get those. Can you all discuss security and encryption measures?
Yeah, I will go over security once I go over after I go over the API, that the second API that we have, which is extract.
Excellent. And then one question Andrea did answer, but let me post it to everyone's benefit. How accurate is extraction of medical survey data that is based on handwritten entries?
I will rely on Andrea's answer, but also like I can show more examples of handwritten even here. We have the handwritten text of this information. It's able to extract that. This one has like a bit of crossover with the second key. It's able to detect the 5 times a week, and then 10 is crossfit. It would be helpful for you to test it with your own documents too.
Great questions. Please continue.
What we did here was go over the parse API. Now I will go over extract, which is the field extraction or specific information extraction that we have. So let's just take one example here, maybe a test report. So for this test report, you can go to our extract tab. It already provides some suggested field. This is just some suggested field based on the document information here. So maybe, for example, laboratory information, email address, name, all of that. The blood count, like the results. So like what is the unit, what is the result, what was the investigation about, and what was the reference value. This is all extracted in different types formats. So like this is a JSON schema. So it has an array of objects, and then all of them are like strings because these are values or text values. If you already know what you want to extract, you can also upload your own JSON schema, but you can also like just prompt to schema where you can write a prompt and it will convert it into a schema for you. So for example, I want to extract patient information, name, age, gender, and then PID number. And I can go ahead and generate a schema. This will understand like how this information should be extracted. Is this a string? Is this an array, etc. It grouped all of this information inside the object patient and defined the name, age, gender, and PID. We have 3 fields. This is the field name itself. The name, age, gender, and PID is the field name itself. This is field types. We have multiple field types here. String is just extraction of string. Enum is if you have choices, like you want the extraction to select from one of the options that you have provided. So it can be multi-choice or single choice answer. Date, formatted date will also be extracted. Boolean is like if you want to extract only true or not true, you should be able to select Boolean. Number, and then same options are available for in an array. So if you have multiple records of information in your document, you should be able to select array. So name, let's say age, I want to extract it in number. I will be able to convert the field types right here. And then the field description is just more information about what you want to extract. So if you have a very vague field or the field name changes across documents, you should be able to define that in field description, which is an additional context for the extraction model to extract the information. PID can also be number, so I will just put number here. And let's say gender, I will put enum, and then say male or female. And I will run the schema, and it extracted all the values. This extraction is done on top of our parsing. So we have already done the parsing and converted everything in Markdown, and the extraction is done on top of it. So you don't have to like parse every time you want to extract information. You have one parse, and then you can extract on top of it multiple times. And so Yashin Patel is extracted as the name. And once I click on it, it should be able to reference where this information is coming from. And the way it's able to do it and how you can replicate it in the API is based on this reference ID. This reference ID connects back to our parse JSON, and this reference ID will match the chunk of where this information was extracted about the patient. Yeah, so it's able to connect all the information on where it was extracted from. And based on our different types, it also like followed the types itself and extracted the results. I have another similar example for the patient intake form. Here, I want to extract the name, date of birth of the patient, and then the gender itself. In terms of patient history, I have tried like using Boolean and saying if the patient have a pacemaker or not, and it's detected as false, which is also the correct option that was selected in the document. And then another one is attestation. So if this document is signed or not, it's again a Boolean data field in my schema. And it has detected that the document is signed and it's correctly detected as true. And then this is like the array of string type. I'm asking it to list all the medical conditions that the patient has right now. And it extracted all the ones that were circled. So even though we extracted them as check boxes, it's able to convert it in the different schema types you want. Right now, I just want to extract them as strings. It's able to detect the ones that were selected and extract them as a list of medical conditions. Once you have built your schema, we have a very good tool where you can click on code, and this just provides you with the code from our library and the API as well. So you can either use our library, which has a lot more features to get you started, or you can directly use the API as well if it is fitting for your need. You can download the schema and also test it on multiple other documents too before you get started with the code. I have one more example, and then I can go into documentation or like how our APIs are structured and the documentation as well. This is a complex accident form, but but it has multiple columns. And the column ordering is important because vehicle A, the information is across this, like one column, vehicle B information is across this another column. So what we have done is like, again, went through parse, detected all these chunks and ordered them correctly. So this is the 8th chunk, this is 9th, 10th, 11th. So like it's in correct order. Once this is done, I have extracted the information about vehicle A, which is across different chunks. So vehicle A, the value itself is present here, and I'm extracting the name of the person, insured person in vehicle A. But I also want to know the insurance company, where it was, where the insurance was coming from. This is in a separate chunk, but it's still able to find that this is related to vehicle A because our ordering is correct, and also extract that information. Now I will go into more explanation about the API as well, and our documentation related to the API. So as I mentioned, we have two APIs. One is parse API. It will take any kind of document formats as an input and then output it in a markdown and a structured JSON format. The JSON will have the markdown values, but also the grounding for the where this information was from the document. We have another API called Extract API, where you can take the markdown, be it the markdown that is available from parse or any other markdown that you have, and provide a schema. The schema is like what you want to extract from these documents, and it will output a JSON with the results for the schema, and then also like a metadata of like where you can reference it if you're using our markdown, where you can reference it in your original document that you had. You can do this multiple times. You can have the same input markdown from the same PDF, but you can run extract multiple times with different schemas, different outputting different results. So you don't have to parse again and again as you're going through this extraction. And yes, so this markdown, the output of the parse API is the markdown that the extract API will take. It can take other markdowns as well. Going more into documentation, if you are on our playground, you can click on API docs and it will lead you to our docs.landing.ai. And you can start with quick start, where you get the information about how to set up the API key, how to get started with parsing a document, and then how to get started with extracting a document with our library. We have different features available using our library and even API. One of the ones that I wanted to highlight is our model versioning. So we constantly improve our models for both parse and extract. You can subscribe to the extract latest model to get the latest update as soon as possible. But if you are in production and want to not change it a lot, once we update our model, you can use a particular model version. So you should be able to get that version and only parse your documents with that model version, and then maybe do the testing on your time on how it improves on your use case. The new model improves on your use cases, and also add that into your latest model. In terms of security questions, we have documentation about security on our documents platform. We have a trust center which talks about all the compliances that we have currently, and also our zero data retention policy. We are SOC 2 Type 2 compliant. We are HIPAA compliant as well. And we are able to sign BAAs. Specifically for healthcare and life science, this would be very helpful. We are able to sign BAAs for subscriptions starting at a very minimal price. I will go over subscription pricing soon. We are also GDPR compliant in our EU platform. So we have both US hosted platform and EU hosted APIs. We are GDPR compliant in the EU hosted environment. And then questions about HIPAA will also lead you to security and compliance page, where you can find more information about all of our compliances and the way we process or store your data. If you need HIPAA compliance or you are just wanting zero data retention, you will find information about zero data retention option here. This option is also available for our subscription users and not pay-as-you-go users. With this, you should be able to process all your documents without us like even storing it at all with all of our APIs. We don't store your documents, we don't store the schemas that you provide or any kind of output that we provide to you. So it's completely no data retention from our side. I will quickly go over the pricing questions and then come to like more information about deployment. If I go to landing.ai/pricing, you should be able to find the information for ADE itself. We have different tiers based on your need. As you're starting to test and maybe like starting a POC, you can go with a pay as you go. If you have like documents that are private or like need security compliances, you should not use those documents with pay as you go because we store the documents for our verification. But you can test with like more open source documents or similar documents that you can find with on internet. This is scaling with your needs, so you can just buy as many credits as you want and parse with the pay-as-you-go model. All the features that we have in subscription and tiers and enterprise tiers are available here, except for the security ones that I will talk about. With this, you will be able to get started quickly with ADE and not be waiting for you to get started just testing it. With the subscription, we start at a very small amount of $250 per month, but this gives you like an organization support, so you should be able to invite other members to the same org, and then parse and manage all your ADE related parsing processing in one place. You should also be able to enable zero data retention option, and so we don't store any of your documents or pages or results. This is available at an extra credit on top of the parsing and extract credit. We are also able to sign BA along with zero data retention starting at $250 per month. But as you scale and as your needs scale, you should be able to go to a further subscription tiers, or like even visionary plan, which has 30% more credits from like the pay-as-you-go plan. If you want custom LSLAs or like deployment options, I will talk about enterprise VPC options too soon. For the parsing and extract itself, you should be able to find how credits work, like how our credits work, how do we charge for parse and extract in our documentation at docs.landing.ai. Any questions so far?
Are we able to get zero data retention with pay-as-you-go?
Unfortunately not. We are able to get it starting with like as I mentioned, like a $250 subscription, but you will need to have a subscription to get started with zero data retention.
You're good to go. Continue, please.
Okay. So in terms of deployment options, we have like multitude of deployment options, but ADE Cloud, like the one hosted by us, is the fastest way for you to get started with ADE and start seeing results and start implementing it in how your downstream applications would work with ADE. This is completely managed by us. We have SOC2 type 2 compliance for it, HIPAA and BA and ZDR for this, and also has a uptime SLA from our side. This will provide you best in class like security as well as manage updates and communication and get you the latest model as soon as it comes out with all this compliance that is present. You can find more information, as I mentioned, in Trust Portal and then the security page as well. We also have VPL link if AD Cloud doesn't work for you. This is hosted by us, but this is more single tenant, so it's like separated from the multi-tenant cloud that we have. We also have more involved managed services by you, which is VPC. We are able to deploy VPCs on AWS, Azure, or GCP. This will take time for implementation, as well as like be slow in like the upgrades that we do on our cloud API with the model as well as the features that we add. But it should be providing you with the most security from this for ADE. Since we have the VPC deployment, we will deploy our foundation models that we use for detecting and extracting information. But we also use LLMs for some verification or some extractions. You can bring your own LLMs, and we should be good with like using that LLM. We kind of scale well with like different major LLMs like Gemini, OpenAI, or Claude, because our foundation models are stronger to work with these LLMs. That's all I have for today.
This is awesome. Thank you for joining us today. Have a great day.